Hey, everyone out there in the live stream, either watching live or watching the replay. Thank you for being here. Hey, Stan.
Hello, how's it going?
Hey, it's going well. Welcome to the live stream and almost to the podcast. So we're going to talk about some fun Anaconda stuff. You ready to kick this off?
Yeah, let's do it.
All right. Stan, welcome to Talk Python to me.
Hey, nice to be here.
Yeah, it's great to have you here. I'm super excited to talk about data science things, Anaconda things, and we'll even squeeze a little one of my favorites, the Apple M1 stuff, mixed in with data science.
Yep.
So it should be a fun conversation.
Cool. Looking forward to it. Yeah, it should be good. I'm also very excited about the M1. So.
Nice. Yeah, we can geek out about that a little bit. That'll be fun. But before we get there, let's just start with your story. How did you get into programming in Python?
Yeah, programming started as a kid. Dating myself here, I learned to program BASIC on the Osborne 1, a suitcase of a computer that we happened to have as a kid. And then eventually picked up C and stuff like that. Didn't learn Python until college, mostly because I was frustrated with Perl. That I just found that Perl just never fit in my brain right. And so I was like, well, what other scripting languages are there? And I found Python. And that was a huge game changer. I didn't really use it professionally or like super seriously until grad school, when I had a summer research job and I realized that this new thing called NumPy could help me do my analysis. And so that was when I really started to pick up Python seriously. And now here I am, basically.
Yeah, what were you studying in grad school?
I was doing physics. So I did particle physics and used Python quite extensively, actually, throughout my research. And C++, unfortunately, for better or worse. But that's how I always ended up kind of being the software person on experiments. So when I was leaving academia, going into software engineering kind of was a logical step for me.
Yeah, that's really cool. I was studying math in grad school and did a lot of programming as well. And I just sort of trended more and more towards the computer side and decided that was the path as well. But it's cool. A lot of the sort of logical thinking, problem solving you learn in physics or math or whatever, they translate pretty well to programming.
Yeah, and definitely, working on large experiments. A lot of the sort of soft skills of software engineering, things like how do you coordinate with people, how do you design software for multiple people to use, that sort of thing. I inadvertently was learning how to be a software manager as a physicist, and then only realized it later when I went into industry.
Yeah, oh, excellent. And how about now? You're over at Anaconda, right?
Yeah, so maybe I'm doing the same thing. So now I'm both a developer and a manager at Anaconda.
It's a direct path from like PhD physics, particle physics to programming to data science at Anaconda. Is that how it goes?
Yeah, I mean we employ a surprising number of scientists who are now software engineers, and so I manage the team that does a lot of the open source at Anaconda. So we work on stuff like Numba and Dask and various projects like that. Just recently hired the Piston developers to broaden our scope into more Python JIT optimization kind of stuff. So I'm doing a mix of actual development on some projects as well as just managing strategy, the usual kind of stuff.
Yeah. Well, I suspect most people out there know what Anaconda is, but I have listeners who come from all over. What is Anaconda? It's kind of like a Python you download, but it has its own special advantages, right?
Yeah, I mean, where we came out of, and still is our main focus, is how to get Python and just broader data science tools. One of the interesting things about data science is it's not just Python. Most of people are going to have to combine Python, and maybe they don't realize it, but with Fortran and C++ and all the things that underpin all of these amazing libraries. And so a lot of what we do is try to get Python into the hands of data scientists, is get them the latest things and make it easy for them to install on whatever platform they're on. Windows, Mac, Linux, that sort of thing.
Sure.
So the Anaconda has a free called Individual Edition. It's basically a package distribution and installer that lets you get started. And then there are thousands of Conda packages. Conda's the packaging system. There are thousands of Conda packages that you can install where, we or, the broader community have done a lot of the hard work to make sure all of those compiled packages are built to run on your system.
That's one of the real big challenges of the data science stuff, is getting it compiled for your system. Because if I use requests, it's, pip install requests. I probably, maybe it runs a setup high, maybe it just comes down as a wheel. I don't know, but it's just pure Python, and there's not a whole lot of magic. If I'm really getting there far out there, maybe I'm using SQL Alchemy and it has some C optimizations. It will try to compile, and if it doesn't, well, it'll run some slower Python version probably. But in the data science world, you've got really heavy dependencies, right? Like, as you said, stuff that requires a Fortran compiler on your computer. I don't know if I have a Fortran compiler on my Mac. I'm pretty sure I don't, but maybe it's hidden there. Probably not, right? And as maybe C++, probably have a C++ compiler, but maybe not the right one, maybe not the right version. Maybe my path is not set up right. And plus it's slow, right? All of these things are a challenge. So Anaconda tries to basically be, let's pre-build that stuff with a tool chain that we know will work and then deliver you the final binaries, right? The challenge with that for a lot of tooling is it's downloaded and installed to different machines with different architectures, right? So you've gone and built stuff for Mac OS, you built stuff for Linux, you built stuff for Windows and whatnot. Is that right?
Yeah. Building software is non-trivial, and no matter how much a developer tries to automate it so that things just work, it helps to have someone do a little bit of quality control and a little bit of just deciding how to set all the switches to make sure that you get a thing that works so that you can just get going quickly. Early on, I remember in the sort of 2014, 2015 era, Anaconda was extremely popular with Windows users who did not have a lot of good options for how to get this stuff.
Right.
Like with Linux, you could kind of get it together and get it going if you were motivated. On Windows, it was often just like very much I don't know what to do. And so making it sort of one-stop shopping for all of these packages. And another thing we wanted to do is make sure that there was a whole community of package building around it. It wasn't just us. So things like CondaForge is a community of package builders that we are part of and hugely support. Because there's a long tail. There's always going to be stuff that is going to be, we're never going to get around to packaging.
Right. But, there's important stuff that you're like, this is essential. So NumPy, Matplotlib, and so on. Like, you all take control of making sure that that one gets out. But there's some, biology library that people don't know about that you're not in charge of. And that's what the CondaForge plus Conda is like, sort of like pip and PyPI, but also in a slightly more structured way.
Yeah. And that was why, Conda was built to help make it so that it is possible for this community to grow up, for people to package things that aren't Python at all that you might need, all kinds of stuff like that. And there's always going to be, in your specific scientific discipline. I mean, so for example, BioConda is a really interesting distribution of packages built by the bioinformatics community. Built on Conda, but they have all of the packages that they care about, and many of which I've never heard of, and aren't in common use, but are really important to that scientific discipline.
Yeah, it's really amazing that that's out there. That's great. Out in the live stream, we have a question from Neil Heather. Hey, Neil. I mentioned Linux, Windows, Mac OS. Neil asked, does Anaconda work on Raspberry Pi OS, as in ARM64?
Yeah, so the answer to that is Anaconda, not yet. CondaForge does have a set of community-built packages for Raspberry Pi OS. The main challenge there is actually we just a couple months ago announced ARM64 support, but it was aimed at the server ARM machines that are running ARM 8.2 instruction set, which the Raspberry Pi is 8.0. And so the packages we built, which will work great on server ARM, are using some instructions that Raspberry Pis can't support. But CondaForge, so if you go look up CondaForge and Raspberry Pi, you'll find some instructions on how to install for that.
Yeah, excellent. Yeah, it's really cool that it works over there. Yeah. And ARM is interesting, right? So let's talk a little bit about that, because I find that this whole Apple Silicon move, they created their M1 processor, and they said, you know what, we're dropping Intel, dropping x86, more importantly, and we're going to switch to basically iPad processors, slightly amped up iPad processors that turn out to be really, really fast, which is actually blew my mind and was unexpected. But I think the success of Apple is actually going to encourage others to do this as well. And it's going to add, more platforms that things like Anaconda and Forge and stuff are going to have to support, right? So
Yep.
there's a cool article over here by you on Anaconda called "A Python Data Scientist's Guide to the Apple Silicon Transition."
Yeah, this was I'm a huge chip nerd, just due to the background in thinking about optimization and performance, and so this came out of some experiments I was doing to just understand. I mean, we got some M1 Mac Minis into our data center and started immediately playing with them, and I realized after some I should take the stuff I was learning and finding and put it together in a document for other people, because I couldn't find this information anywhere organized in a way that was for me as a Python developer, I was having a hard time putting it all together.
Right. There was some anecdotal stuff about just like, this kind of works for me, or this is kind of fast, or this is kind of slow, but this is a little more, like, here's the whole picture and what the history is and where it's going and what it means, and specifically focused on the Conda side of things, right?
Yeah, and even just the Python side, it's sort of an interesting problem of, Python's an interpreted language, so you're like, well, I don't have any machine code to worry about, right? But the interpreter, of course, is compiled, so you at least need that, and then many Python packages also contain compiled bits, and you'll need those too. And this is an interesting broad problem for the whole Python ecosystem to try and tackle, because that's not too often a whole new platform kind of just appears. Making it a whole new architecture takes a while.
It absolutely does. I think there's a lot of interesting benefits to come. I do want to point out for people listening, if you jump over to the PSF JetBrains Python Developer Survey, the most recent one from 2020, and you look around a bit, you'll see that while we don't run production stuff on Mac OS that much, 29% of the developers are using Mac OS to develop Python code, right? So Apple's pledged that we're going to take 100% of this and move it over to Silicon. Means almost a third of the people running Python in a couple of years will be under this environment, right? And even if you have a Windows or Linux machine and you don't care about Mac OS, you may be maintaining a package for people who do. And that means Apple Silicon, right?
Yeah, and it's interesting. There's a whole, just other stuff you take for granted. The availability of free continuous integration services that has been transformative for the open source community. It's really improved the software quality that all these open source projects can automatically run their tests and build packages every time there's a new change. However, something like this comes out, and until you get ARM Macs into these services, and if they're, until they're freely available, a lot of the infrastructure of these open source projects, they don't have a way to test on an M1 Mac except manually if they happen to have one, and they don't have a way to automate their build on an M1 Mac until that sorts out.
Yeah, and thinking about the workflow here, there's two challenges that this presents. One is you want to do a git push production or git push to some branch or tag it, and that's going to trigger a CI build that might fork off to run a Windows compile, a Linux compile, a Mac compile, generate some platform specific wheels with like Fortran compiled in there or whatever, and then you're going to ship that off. If that CI system doesn't have an Apple Silicon machine, it can't build for Apple Silicon, right?
Yep.
Right.
And,
so and where do you go to the
time?
Yeah, sorry. Well, where do you get M1 in the cloud, right? As a normal, I know there's a few hosted places, but as a normal GitHub or an Azure, it's not common to just go grab a bunch of those and pile them up, right?
Yeah, it'll take time. Eventually, in the same way that, I was thinking back to, go back 4 or 5 years ago, there wasn't a whole lot of options for Windows CI available. There were a couple of providers, and then there was sort of a huge change, and then pretty much everyone offered a Windows option, and they were faster and all of this stuff. And so I think, but that took time, and I think that's the thing is the hardware is in people's hands now, and it's just going to get more and more. and it's unclear how quickly we can catch up.
Yeah,
That's going to be a challenge for all of us.
it's absolutely going to be a challenge. It's interesting. I hope that we get there soon. The other problem in this same workflow is I was actually just looking at some NumPy issues, specifically issue 18,143. I'm sure people have that right off the top of their head. The title is "Please Provide Universal 2 Wheels for Mac OS," and there's a huge, long conversation about. I mean, this is like many lines of many messages in the thread. And one of the problems they brought up is like, look, we can find a way to compile the binary bits, the C++ bits for M1, but we can't test it. Like, if we can't, we as developers cannot run this output. Like, it's a little sketchy to just compile and ship it to the world. And to be fair, this is on January 9th of 2021 when it was still hard. You know, these things were still shipping and still arriving. It was not like just go to the Apple store and pick one up.
Yeah. It's I mean, as an interesting example, I mean, CondaForge was able to get Conda packages for Apple Silicon out pretty quickly, but they did it with a clever sort of cross compilation strategy where they were building on x86 Macs the ARM packages and pushing them out. And so, but they had enough people manually testing that they had confidence in the process that it was okay. But that's very different than how they build other packages, which are built and tested immediately. Automatically, and if they fail test, they don't get uploaded. So that's it's a risk, but it helped get the software out in people's hands quicker. But yeah, long term, we need to get these machines onto all these CI systems so that we can use the same techniques we've built up over the years to ensure we have quality software.
Yeah, I think we'll get there, but it's just going to take some time, right?
Yep. Yeah.
Let's see. Neil on Livestream says, speaking of open source, Apple is rumored to be hiring experts in RISC v5 to perhaps move away from having to pay licensing fees to ARM. Yeah, I'm not sure about that, but interesting.
Yeah, I mean, it's what's interesting here is the I mean, other chip architectures have been around for a long time, but until very recently, average users didn't have to think about x86 versus ARM. ARM was for mobile phones and other, and never had to worry about PowerPC or anything.
Not for real computers. Yeah.
And so, but now, once going from 1 to 2 is a big step. Now the floodgates are open, and now we're thinking about, well, what else is out there? I mean, RISC-V. I'm not sure how you say it. I think RISC-V is what you call it. Is an interesting thing, and has even being a completely open standard, you don't have to even pay licensing fees, as mentioned. I don't know if Apple's going to make this transition again so quickly, but I can guarantee you that everyone probably somewhere in a basement is thinking about it, maybe doing some experiments. But yeah, chips move slowly, but it's interesting.
This is not this is not a thing you can change very frequently and drag the developers along. I mean, we're talking about all the challenges that are just down the pipeline from that. Yeah. Very interesting. All right. Well, let's just talk a little bit about this. First, you're excited about these as a data scientist?
Yeah, I'm really for sort of two reasons. I mean, one thing that's interesting is just the power efficiency. There was a talk long ago from the chief scientist at NVIDIA, which really had an impression on me, in which he, paraphrasing roughly, basically said that because everything is now power constrained, power efficiency equals performance. Yeah. In a way that is, normally you just think, well, just put more power in there, but that heat has to go somewhere. So we long since hit that wall. And so now you just have to get more efficient to get more performance.
Right. I mean, you can get more, you can get like larger power supplies and larger computers. I have a gaming sim computer, and it is so loud if you get it going full power. Like if the windows are open, you can hear it outside the house. It's literally that loud. But at the same time, it's not just on your personal computer, in the cloud and at places like that, right? You pay not just, how much performance you get. There's some sort of combination of how much energy does that particular processor take to run. And if it's 1/5, you might be able to buy more cloud compute per dollar.
Yeah,
Yeah.
power and cooling is a huge part of computer, data center expenses, and even just you can put maybe 1 to 300 watts into a CPU. You're not going to put multiple kilowatts in there or something, and so where is that? What else can you do? And a lot of that is that Moore's law is driven a lot by just every time you shrink the process, you do get more power efficient. But now it's interesting to think about architectures that have been sort of thought of that ARM has come into its own in a extremely power constrained environment, and so now we're letting it loose on a laptop which has way more power compared to a cell phone available.
Yeah. You're like, well, what could we do if we fed it right into the socket in the wall?
Yeah, and what happens when I put it in the data center? So
I think ARM in the data center is going to be really important.
Yeah, I think it's definitely. I'd always expected that to come before the desktop. To be honest, I was surprised, as many people were, by the suddenness of the Apple transition, because I had assumed this maybe would happen much after we all got used to ARM in the data center, where you're probably running Linux and it's easy to recompile compared to Mac and stuff like that. But
yeah, that's what I thought as well. The payoff is so high, right? They spend so much energy on both direct electricity as well as then cooling from the waste heat from that energy, that the payoff is just completely clear, right? All right, so let's see. A couple of things that you pointed out that make a big difference here is obviously ARM versus x86, built-in on-chip GPU, the whole system as a system on a chip thing rather than a bunch of pieces going through motherboard is pretty interesting. But I think maybe the most interesting one has to do with the acceleration, things like the Apple neural engine that's built in and whatnot. It sounds like the data science libraries in general are not targeting the built-in neural engines yet, but maybe they should. Maybe they will in the future. I don't know.
Yeah, it's something that we're going to have to figure out because I think it was a bit of chicken and the egg that until this happened, you didn't have this kind of hardware just sitting on people's desks. And you weren't going to run data science stuff on your phone. So now that it's here, now the question is, okay, what can we do with it? Right now, for example, for the Apple Neural Engine, you can take advantage of it using something called CoreML Tools, which actually did a webinar some time back on, but that's like for basically you've trained a model and you want to run inference on it more efficiently and quickly. But that's it. There's an alpha release of TensorFlow that's GPU accelerated, and it would take advantage of the on the M1 if you're running it there. But that's super early, and there's a lot more opportunities like that. But again, that will take time to adapt.
It will. I suspect as there's bigger gains to be had, they'll probably more likely to be adopted, right? So, for example, I have my Mac Mini here that I just completely love, but it's not that powerful, say, compared to like a GeForce video card or something like that.
Yep.
But if Apple announces something like a huge Apple Pro, Mac Pro, with many 128 cores instead of 16 or whatever, right? Then all of a sudden, in the neural engine, that neural engine becomes really interesting, right? Maybe it's worth going to the extra effort of writing specific code for it.
Yeah. Well, that's the other thing that's interesting about this is we've only seen one of these chips, and it is by definition the slowest one that will ever be made.
Exactly.
And so we don't even know how. What is it going to be like to scale up? I mean, one of those things that is if you're targeting that big desktop user, how are they going to scale this up? This all fit on one package. Can they still do that? Will they have to split out into multiple packages? There's a lot of engineering challenges that they have to solve, and we're not sure how they're going to solve them yet out on the outside. So,
absolutely,
we're going to have to see.
It's going to be exciting to see that come along here. All right, so let's touch on just a couple of things. Getting Python packages for M1. What are some of the options there?
Yeah, so the status still is roughly how I have in this article, which is basically you can use pip to install stuff if wheels have been built, and a number of packages like NumPy have started to catch up and have wheels that will run on the M1. Another option, which works surprisingly well, is to just use an x86 Python packaging distribution.
Yeah, I think that's actually what I'm doing because it just runs over Rosetta 2.
Yeah,
and it's
just
pretty fast.
Works.
Yeah.
It is shocking. I mean, Rosetta 2 on average, I'm finding is sort of like a 20% speed hit, which for an entire architecture switch is amazing.
Yeah.
That I've never seen that before. Or you can use CondaForge has, as I mentioned earlier, their sort of experimental Mac OS ARM package distribution, which doesn't have everything, but has a lot of things, and is using then, it is all built for ARM. There's no translation or anything going on there.
Right. And on python.org, I believe the Python is that if you go and download, I believe it's a universal binary now. Pretty sure. So that means it'll adapt and just run on ARM or run on x86. You just get one binary. The NumPy conversation was kind of around that as well, I believe. All right. You did some performance analysis on the performance cores versus efficiency cores. That was pretty interesting. And so that was pretty similar to hyper-threading. If you want to run Linux or Windows, you basically got to go Docker or Parallels. And then I guess maybe the last thing is like, let's wrap up this subtopic with like pros and cons for data scientists. People out there listening, they're like, I can't take hearing about how cool the M1 is anymore. Maybe I'm going to have to get one of these. Like, should they? Like, what do you think as a data scientist?
Yeah, as a data scientist, my takeaway from all the testing was you should be really excited about this, but I would wait unless you are doing what I would describe as a little bit of data science on the side and not a huge amount. Mainly because what they've proven is the architecture has great performance and great battery life. The thing we still have to see is how are they going to get more RAM in there? How are they going to get more cores in there? And then also when is the rest of the ecosystem going to catch up on package support? So honestly, I'm if you're interested in sort of bleeding edge, knowing what's coming, I would totally jump in. If you want this for your day to day, I would probably still wait and see what comes out next, because I think a data scientist especially is going to want some of the more cores and more RAM especially than what these machines offer.
Right. There's always remote desktop or SSH or something like that, right? If you've got an Intel machine sitting around, you can just connect over the network locally.
Yep.
Yeah, very cool. All right, excellent one. I just want to give a quick mention that Paul Everett from JetBrains and I did a Python developer explores Apple's M1 way back in December 11th of 2020, right when this thing came out. So people can check that. I'll put that in the show notes as well. All right, let's talk about the state of data science 2021. How did you all find out about this? How do you know the state?
Yeah, so this is something we've been doing for a few years now. I mean, since we have a big data scientist audience, a couple years back, we decided, hey, let's ask them about what challenges they're seeing in their jobs, and then publish the results so that the whole industry can learn a little bit more about what are data scientists seeing in their day-to-day jobs that's going well, going poorly, where do they want to see improvements, what are they sort of feeling and thinking.
Yeah. So you got a bunch of people to come fill out the survey and give you some feedback. And we 140 plus countries, so we have pretty good reach across the world. And more than 4,200 people took the survey, so it's we got a lot of responses. It's always amazing to see. Yeah, quick side thought here, I guess. So you've got in that survey, which I'll link to the PDF results in the show notes, you've got all the countries highlighted, and obviously North America is basically completely lit up as like a popular place of results. So is Western Europe, Australia, and even Brazil. Africa is pretty on the side. What else can be done to get sort of more Python, more data science going in Africa, do you think? If you have any thoughts on that?
That's an excellent question. I don't, that's actually might be a good question for a future survey, to be honest, is I can speculate, I don't know if it's, access to the computing, or if it's bandwidth, or if it's, resources available in the local languages. There's all sorts of
one thing that is really nice about Python and data science is so much of the stuff is free, right? So it's not like, oh, you got to pay, some huge Oracle database license to use it or whatever, right? So there's a real possibility of that. So I don't really know either, but let's see. There's the standard stuff about like education level. I guess one of the areas maybe we could start on is just people who are doing data science, like where where do they live in the organization, right? Are they the CEO? Are they vice president? A good portion of them were 50% is either senior folks or managers. That's kind of interesting, right?
Yeah, I can see it sort of coming out of data science as helping in decision making and that sort of thing. And
Exactly.
so I can see it gravitating towards the decision makers in an organization, and that sort of thing. I mean, one of the interesting things that it maybe is in a later one of the pages is how spread out data science is across the different departments as well. That there was, obviously IT and R&D show up higher than the others, but you kind
Yeah.
of see a long tail in all the departments. And my theory on that is I think we're seeing data science evolving into sort of a profession and a professional skill, if that makes sense. So in the same way that knowledge workers are always expected to do writing and to know how to write,
Yeah.
but we also hire professional technical writers. I think we're getting into a space where everyone will need to have some numerical literacy and data science skills, even while we also employ professional data scientists.
Is it the new Excel? Like if I'm a manager, I don't know how to use Excel, people are going to go, what is wrong with you? How did you get here? Right. You're going to have to know how to use a spreadsheet. I mean, it could be Google Sheets or whatever, but something like that to, pull in data, sum it up, put it in a graph and so on. And are you seeing that more formal data science, Jupyter type stuff is kind of edging in on that world?
Yeah, it's going to, again, I think we'll have to see sort of how the tools settle out. One thing I know for sure is that you'll have to at least become familiar with the concepts, so that even if the people doing the data science and reporting to you are using whatever their favorite tool set is, at least understanding their workflow and how data, goes through that life cycle, and data cleaning and modeling and inference and all of those things. You'll have to understand that at least enough to interpret what is being told and ask the right questions about where did the data
So
come
if somebody
from, how did
comes to you and
filter it?
says, you asked me this question, so I put together a Jupyter notebook that's using PyTorch forecasting. Maybe you can do none of those, but you should kind of understand the
Yes.
realm of what that means, something like that.
Yes, you'll have to know at least what steps they had to go through to get to the answer, so you can ask good questions about. Because if you are a decision maker, you need to be able to kind of defend your decision, which means you're going to have to at least understand, what went into the inputs into that decision. So,
Yeah. Well, we bought that company because Jeff over in business analytics said it was a good idea. Turned out he didn't replace the not a number section, and that really broke it. So
yeah.
I guess one of the requisite topics we should talk about is probably COVID-19, because that was going to be over in a few weeks or months, but then it wasn't. So it's still ongoing. And one of the things that you all asked about and studied was basically, did COVID-19 and more specifically sort of the shutdown as a result of it result in more data science, less data science, increased investment, not so much? What did you all find there?
Yeah. So interestingly, I think we found that there was a sort of all different organizations had every possible answer. So,
Right. So yes.
the about a third decreased investment, but a quarter increased investment, and another quarter stayed the same. And so that's, there wasn't one definitive answer that everyone had for that, which is, I think, probably has a lot to do with where data science is at in their organization. I mean, on one hand, data science is an activity that is easy to do remotely. You can, there are a lot of jobs that you can't do remotely. Data science is one you could do remotely. So that part isn't an obstacle so much. But a lot of it also has to do with risk. I mean, everyone when they faced this was thinking with their business hats on, what is the risk to my organization of an unknown economic impact of this pandemic? And so a lot of places might have viewed their data science as being a risky, still early kind of thing, and so let's pull back a little bit. Let's not spend the money.
Is it optional? Okay, we cancel it for a while. We put it on hold.
Yeah,
or is it core?
But clearly, for some organizations, it was so important they put more money in, and so a lot of it had to do with just where you're at in the journey, I think.
Yeah, absolutely. Let's see. Industries, you found out where people were doing data science. Obviously, technology, right? Tech companies. I'm guessing this is like Airbnb, Netflix, those kinds of places. There's a lot of data science happening those worlds. Academic was number 2.
Yeah, I mean, data science is still a actively researched thing. I mean, as you see, sometimes it's hard to keep up with all of the new advancements and changes and everything, not just in the software but in techniques. And so academia is super busy on this.
Yeah.
Banking is also a top one because I kind of think of banking and finance as being some of the original corporate data scientists in some ways, and so obviously they're. It was interesting to see automotive actually score so highly.
That's the one that surprised me as well. Automotive is 6%, and the highest industry was 10%. So yeah, that's really quite high. I wonder how much of that is self-driving cars.
I don't know that. I mean, the other one is, as we've heard with the chip shortages, supply chain logistics is an interesting use of data science to try and predict how much supply of all of the things you're going to have where and when, and how should you transport stuff. And I imagine car manufacturing is especially challenging, especially now.
Interesting. Yeah, they really shot themselves in the foot, didn't they, when they said, you know what, all these extra chips, people aren't going to need cars. They're not going to buy cars during this downturn. So let's cancel our order. We'll just pick it back up in 6 months. And 6 months later, there are no chips to be had. So there we have it. Yeah, I mean, GM, I think it's even shutting down a significant portion of their production in the U.S. because they're just out of chips, which is crazy. Antonio out in the live stream says he's doing data science with his team in the energy, oil, and gas industry, and we're not the only ones. It's funny that doesn't appear in the list.
We do have energy, but they're down to 2%. Again, all of the percentages are low because there's so many industries and everyone was all over the place.
Yeah, absolutely. Cool. Let's see. Team size is interesting. I think one of the things that it's interesting here is when I think of software developers, they kind of cluster together in like development team groups, right? They've got the software development department, maybe in a company, or a team building a piece of software or running a website. To me, data scientists feel like they might be more embedded within little groups. There might be a data scientist in the marketing department, a data scientist in the DevOps department, and so on. Is that maybe correct?
Yeah, I think we've seen companies actually do both at the same time, even where sometimes they'll have, I mean, one of the things we have listed is a data science center of excellence. And what that ends up being is a group that is pathfinding for an organization. They're saying, okay, these are the best practices. These are the tools. This is what to do. Figuring that out and then rolling it out to all the departments who have their embedded data scientists who can take advantage of that. Because I think it's valuable to have a data scientist embedded in the department, because one of the most important things as a data scientist is your understanding of the data you're analyzing and your familiarity with it.
Right.
And I would really prefer the person analyzing, car supply chains understand what goes into that and also know data science, as opposed to a data scientist for whom it's all numbers and they don't know.
Right. If you could trade absolute expertise in Git versus a really good understanding of the problem domain, you're probably better off going, you know what, just keep zipping it up and just really answer these questions well.
Yeah.
Right? You don't actually have to make that trade-off, but I agree that domain knowledge is more important here. Yeah. So IT had the highest. So think of the departments where data scientists live. IT was pretty high, then R&D, and then this data center of excellence you spoke about. Then ops, finance, administration, marketing, human resources. It's really spread out, which is sort of what I was getting at before.
Yeah. So I think there are a lot of. Seeing a lot of organizations build their data science expertise ground up, department by department, and then maybe we'll coalesce some of it into a single department at some point.
Right. Maybe that department makes like the APIs for the rest of the sort of isolated folks and so on. One that was interesting is how do you spend your time? I mean, you think about these AI models or these plotly graphs and all these things that data scientists produce. Then there's the quote that data cleaning is not the grunge work, it is the work, right? And you sort of have this chart of like, how do you spend your time? And 22% is data preparation, 17% on top of that is data cleaning. And so, it's a pretty significant portion of just getting ready to ask questions.
Yeah. And that's the piece that requires that domain expertise to know what you're looking at, what's relevant, what problems it'll have. No data set is perfect, and no data set is perfect for all questions. And so even if, you can't ever clean the data just once, because what you're doing is preparing it for the questions you're going to ask. And so you need someone who can, understand what's going to happen there and do that. And that's really the expertise you want.
Yeah, cool. Another topic you asked about was barriers to going to production. So some pretty intense graphs, lots of many options across many categories. But basically you asked, what are the roadblocks do you face when moving your models to a production environment?
Yeah.
Go ahead.
Yeah, go ahead. I was going to say, the intense graphs are really that everyone has a slightly different perception of this depending on what seat they're in. Are they the analyst? Are they the data scientist? Are they the DevOps person? Everyone has a different answer for what the roadblocks are.
Right.
And which makes sense because you're going to see what is relevant to your job. When you sum everyone up, you kind of sort of see this even split across IT security. Honestly, what I found interesting was that there was both converting your model from Python or R into another language and also converting from another language into Python and R.
Yeah, exactly. So one of the challenges that people had was, just like you said, recoding models from Python or R into another language. And then the exact reverse. And they were almost exactly tied. 24% of the people said, oh, I got to convert these Python models to Java or whatever. The other people are like, he's got this Java model. I got to get it into Python so I can put it in Fast API on the web, right? Something like that.
Yeah, anecdotally, I mean, I think the maybe we'll have to change the phrasing of this question in the future because putting Python and R together might have conflated a couple of things potentially. So I just know anecdotal evidence. We have talked to customers who their data scientists wrote everything in R, but they didn't want to put R in production, and we're asking them to recode it into Python because Python was okay for production. But I've also had the conversation with people who are like, we do all of our data modeling in Python, and Python's not okay for production. Java's okay for production. And so it's this weird problem of companies have built up how they do deployments on specific languages, and those aren't the languages that people are doing data science in all the time.
Right. And I suspect in the Java one, it's just like we have a bunch of Java APIs and apps running, and those people that do that stuff, they run those apps, and you're going to give us a model that's just going to fit into that world. But if you are already running Python for your web servers, just put it in production. It's already right there, right?
Yep. Yeah.
Yeah, quite interesting. Okay. Let's see. I'll flip through here and find a couple more. One was interesting. It was about open source, enterprise adoption of open source. You maybe want to speak to the results there.
Yeah, I wish we could have asked this question 10 years ago because I think it would have been fascinating to compare to now.
It's the trend that's super interesting. Yeah.
The one of the surprising things for me was the outcome that said, less surprising was 87% of organizations said that they allow the use of open source inside their organization. I think that's not too surprising. I mean, even just Linux is kind of like this sort of baseline. How is your organization functioning without Linux?
Yeah. And then almost what programming language could you choose these days that's not open source, right? You've got Java, you've got .NET, like especially .NET was one that wasn't open source. It was pretty popular. Well, like too late. That's all open source and installed through package managers now. And then the move to Python. And I can hardly think of a language or a place to run where you can't use some level of open source.
Yeah, but the second question, which was, does your employer encourage you to contribute to open source? I was surprised to see 65% said yes. That is a huge fraction, and is interesting because that has not always been that high. I know that we have spoken again to people who have said, hey, I wish I could contribute, but my employer, we just don't have a policy for this, or we don't have a
I used to hear that a lot, right? That it's too complicated. I might leak something out, or bring in some GPL stuff and mess up our commercial product or whatever, right?
Yeah. So I don't know how all these companies have solved that internally, but I am excited to see that there's now a huge potential base of open source contributors out there that commercially that there wasn't before.
I do think there's something about creating a culture for software developers and data scientists where they want to be. And people don't want to be in a place where they're forced to use just proprietary tools that are old and crusty, and they're not allowed to share their work or talk about their work. And, there's people who will do that, but as I would love to be in that environment. Like that's not that feeling. And, talent's hard to come by. So people are probably creating environments that attract the best developers. And the best developers don't want to be locked in a basement and told they can't share or contribute to anything. Yeah.
Yeah, I definitely agree with that.
Another thing that's hot these days, hot as you don't want it, but it's very hot potato style, is supply chain stuff and open source pipeline issues, right? And the survey actually mentioned that one of the problems that people mentioned, one of the reasons that they don't want to use open source is they believed it was insecure, because our $20 billion bank is now depending on this project from Sarah about padding numbers or whatever, right? Like, and if somebody takes over a thing, we're going to pip install a virus into the core trading engine. That's going to be bad, right? Like that's an extreme example. But you did ask about what people are doing to secure basically the code they're acquiring through open source.
Yeah, and this is something, we're interested in just generally because there's a lot more focus on security, and you see more reports about supply chain attacks on software. And so we're curious how different organizations are tackling the problem. The most, unsurprisingly, the most popular answer at 45% was they use a managed repository, which I interpret to mean basically it's kind of like you have a private mirror of the packages that are approved in your organization, and everyone pulls from there, not from the internet directly, which is a smart approach because it gives you a natural sort of gating thing that you can do where there is a review process to bring new software in there.
Yeah.
And so there's a lot of, things here. Obviously, even commercially, we sell a repository for Conda packages for precisely this reason, because customers want some governance and are more than happy to pay us. Team Edition is our on-package repository. And so this was an ask from customers, which is why we built this product. Is they were like, hey, we want your stuff, but we want it inside our firewall. We don't want to go directly to your public repo.
You wanted to opt in to saying, yes, we want the new NumPy, not just, somebody randomly push something out, and so we're going to just grab it and assume that it's good, right?
And you can apply,
not a lot of time. Yeah, go ahead.
I was going to say, you can apply policies as well. That's common, is a lot of places will say no GPL software for various reasons. Or they might say, if they're reported, CVEs, these security reports that, go through NIST, they might say, I want no packages with a CVE more severe than some level. And every IT department wants some handles to control that kind of policy decision making. And so, so that's obviously I think that's why that's the most popular option, is it's the easiest thing to get a handle on.
It is. Yeah, you can set up a private PyPI server. Pretty straightforward. There's a cool article on testdriven.io. But yeah, the Anaconda version that you all offer, that's pretty cool. Mm-hmm. Okay, so 45%. That's high. I didn't expect that many companies to have a private repository.
Yeah,
it's good, but I just expected it to be, lower.
Yeah, although on the other side, that means 55% of those were just downloading random stuff from the internet. So it's good. I think the message is getting out that you have to think about these things from a risk perspective. Yeah.
Another was 33% of the organizations do manual checks against a vulnerability database.
Yeah, so this is what I was describing earlier. These CVE databases are often a common vulnerability. Manual checks, that's a lot of labor. So it'll be interesting to see how many places move to automating that in some fashion in order to, the hard part there is those databases have, again, to data prep and data cleaning, often to make use of those public databases, you need to do some amount of curation because there's a lot of stuff that ends up in there that's mistagged or unclear or whatever. And so a lot of this manual checking is probably also just doing that curation. But I could
one of the things that's nice. Yeah, one of the things that's nice is GitHub will now do automatic PRs for security problems that it knows about, at least.
Yeah, that kind of automation is going to be really important, I think, in the future, just because you can't manually go through all those things.
What are you seeing around source control? Source code, algorithms. These are really important, and people want to keep them super secure. But if they put them on their own private source code repositories, they lose a lot of benefits like automatic vulnerability checking and stuff like that. What's the like GitHub or GitLab versus other stuff? Maybe enterprise GitHub. What's
Yeah,
the
I mean
trends there?
the interesting thing there is yeah, everyone is using source control at some point, and they oftentimes they want it managed inside their firewall, and so yeah, things like GitHub Enterprise and things, and GitLab are pretty popular for that. A lot of times, I think what places will do is they'll use some kind of the next item here, the 30% said they're using a vulnerability scanner. A lot of those vulnerability scanners you can use on your own internal source repositories. And so that way they're not taking advantage of GitHub automatically doing that for them, but they at least have some solution probably for looking for stuff.
Yeah. Yeah, hopefully. All right, let's see. Yeah, also 20% said they have no idea what they're doing. And then another 20% said we're not doing anything. Well, I'm sure of it. Let's maybe close out this overview of the survey results here by talking about Python, Python's popularity. Is it growing? Is it shrinking? Is everyone switching to Julia, or have they all gone to Go? What are they doing?
Yeah, so I think Python's advantage here is being a pretty good at a lot of things, and so it ends up being a natural meeting point of people who are interested in web development and data science or system administration, automation, and so all of that. So I think Python still has some growth to go. But I mean, what's interesting is in our survey, I would say the second most popular was SQL, which has been around forever.
Yeah,
and is going
and
nowhere.
those are often used. Yeah, exactly, and they're often used in parallel, right? Like,
Yeah,
I'm going to do a SQL query and then run some Python code against the results, that type of thing.
yeah, definitely. I'm a big believer in that there is no one language for everything, and there never will be. But there is, a lot of different options that people are looking to. I mean, Go makes sense for a lot of sort of network service kind of things. I mean, Kubernetes is built almost entirely out of Go, but I'm not sure if I'd want to do any data science in Go at this point.
Sure.
And so it's going to always be a mix.
It might not even be that you're doing one or the other. You might be doing both. Like, for example, maybe you've written some core engine in Rust, but then you wrap it in Python to program against it, right? It could be both. I guess it could even be a more combination than that. But yeah, the popularity of Python looks strong. So it looks like it's still right up near the top. I mean, obviously, the group that you polled is somewhat self-selecting, right? But that's still a general trend outside of your space.
Yeah. This is definitely going to be skewed to Python, because otherwise, why are you taking an Anaconda survey? But still, I think, it is definitely something you see broadly in the industry as well.
Yeah. Okay, cool. Anything else you want to add real quick before we wrap this up?
No, I think this has been great.
Yeah. Cool. Speaking of different languages and stuff out in the live stream, Alexander Semenov says, just learned that I can use Rust in Jupyter Lab with some help from Anaconda. My mind is blown. Good job.
Yeah, that's the one thing I should mention about Python is one of the advantages is if you're using Python, you're probably benefiting from most of the languages on the stack, even if you're not writing them. And so the ability of Python to connect to anything is, I think, its strength and why it continues to top these lists.
Yeah. Absolutely. And then Paul out there has a question about the commercial license. And I guess there were some changes to it. Can you maybe speak to that? I don't really track the details well enough to.
Yeah. So what we did was the Anaconda distribution packages have a terms of service that says if you are in an organization above a certain size, we want you to have a commercial license if you're using it in your business. I forgot the exact threshold where that's at. And the reason there was to help support the development of those packages. And I should say, by the way, that terms of service does not apply to CondaForge. Obviously, those are community packages. But if you want the assurances that Anaconda is providing on those packages, and you are a company of a certain size, we would like you to have a commercial license that allows us to support you more directly. It allows us to fund continued work on those packages, and that's sort of it's a sustainability thing, I think. But it's for most people, it's not an issue because they're either below that size or you're just using it individually.
Do you know what that size is? What that cutoff is?
I do not recall off the top of my head, and so I'm afraid to quote a number.
Yeah, sure. No worries. Cool. All right. Well, thanks for giving us that info. I mean, it seems fair that large companies benefiting from your tools contribute back. I think that statement should be applied to open source in general, right? if your company is built on Python, you should give back to the Python space. If your company's built on Java, it's Oracle. I don't know if they need help, but in general, if you're built on top of something, there's a lot of support you can give back, right? It's kind of insane to me that banks that are worth many, many billions of dollars do very little in terms of like directly supporting the people who they're built upon, right? They can hire pay for a couple of people building the core libraries. Like if you're using Flask, right? Support the Flask palettes organization, something like that.
Yeah, and we in turn, take that licensing money, and some fraction of it goes to NumFocus for the broader sort of data science open source community, in addition to us directly funding some open source projects as well.
Yeah, cool. All right, well, we're about out of time, Stan, but let's talk real quickly about Piston, because Piston is not rewriting Python in Rust. It's not replacing it with Python or just moving to Go. It's about making core Python faster, right?
Yeah, this is something, we've been thinking about performance in Python for a long time. One of the early projects that Anaconda created is called Numba. It's a Python compiler. It's focused on numerical use cases, and it really does its best job in dealing with that kind of numerical loop heavy code. But it's not going to optimize your entire program, but optimizes specific functions. And so Numba is very good at a very specific thing. And so we've been thinking for a long time about how we could broaden our impact. And so when I saw that Piston, which among many Python compiler projects, had reemerged in 2020 with a new version written from scratch based on Python 3.8 as a just-in-time compiler in the interpreter. So it's designed to optimize any Python program. It can't necessarily do any given thing as fast as Numba might be for a specific numerical algorithm, but the breadth is really what is interesting to us. And so when I saw this project had emerged, Piston 2.0 kind of came on the scene, I started looking more closely at it, and we started talking with them. And we realized that there's a lot that I think that Piston and Anaconda could do together. And so we have hired the Piston team on to our open source group. So they are funded to work on Piston the same way we fund open source developers to work on other projects. And so we're really, with the benefit that there's other help we can give and resources and infrastructure that we can offer this project. And so we're really excited to see where this is going to go from here.
Yeah, I'm excited as well. All these different things that people are doing to make Python faster for everyone, not just, well, let's try to recompile this loop, but just you run Python and it just goes better. I think that's pretty exciting. We've got the Cinder project from Facebook.
Mm-hmm. Yeah, this is a really good year for Python optimization projects.
I should be careful about typing that into a search engine, but but the Cinder project is not something that's publicly available, really. It's not like a supported improvement, but here's what they did at Instagram. There's a bunch of speed ups. Maybe you all can bring some of that back into regular Python. But yeah, there's a lot of these types of ideas, and yeah, awesome. Looking forward to see what you'll do with this.
And the C Python core developers have even announced that they're going to undertaking a new effort to speed up C Python, and so we're looking to collaborate with them. They're going to have to figure out what they can do within the confines of C Python, because you are the Python interpreter for the world, and so you need to be careful. But there's a lot they're going to do, and we're going to try and share ideas as much as we can, because these are both open source projects.
Right. A lot of the challenges have been in compatibility, right? Like, we could do this, but then C extensions don't work. And those are also important for performance in big ways and other stuff. But yeah, so they do have to be careful, but that's great. All right. Final comment real quick, follow up from Paul. I'd like my company to do more open source, do more to support open source. Any advice on promoting that?
Yeah, I think the best first place to start is identifying what open source does your company absolutely rely on. And especially if you can find an open source project that you absolutely rely on that doesn't seem to be getting a lot of support. And then go look at those projects and see what are they, do they have an established way to donate funds? Do they have, other needs? That's something I think that is easier to sell, is you say, look, our organization absolutely depends on X, whatever this is, as opposed to picking a project at random. It's easier to show a specific business need.
Yeah, for sure. You can say, look, this is the core thing that we do, and it's built on this, rather than, oh, here's some projects I ran across. We should give some of our money away.
Yeah.
That's a harder sell to stockholders, I guess. All right. Well, Stan, this has been really fun. Let me ask you the final two questions before we get out of here. If you're going to write some Python code, what editor do you use?
So if I'm on a terminal, it's Emacs. If I have an actual GUI desktop, I'm usually using VS Code these days.
Okay, cool. And then notable PyPI package or Conda package that you're like, oh, this thing is awesome. People should know about, whatever library.
Yeah, wearing my GPU fan hat, I think a lot more people should know about CuPy. CuPy. It's a Python package that's basically, if you took NumPy but made it run on the GPU. It's the easiest way I can think of to get started in GPU computing, because it just uses NumPy calls that you're familiar with. So I would highly recommend, if you are at all curious about GPU computing, go check out CuPy.
Cool. Yeah, that's a great one. So over there on that computer I have over there, it has a GeForce, but on this one, it obviously doesn't have NVIDIA on my Mac. Does that work? CUDA cores, the CU part of that is for the NVIDIA bits, right? What's my GPU story if I don't have NVIDIA on my machine?
Not as clear. CUDA has kind of come to dominate the space, being sort of first out of the gate. There are a lot more Python projects for CUDA. There are not really clear choices, I think, for AMD or for built-in GPUs at this point. Although I've definitely watched the space. Intel is coming out with their own GPUs sort of this year and starting next year. And they have been collaborating with various open source projects, including the Number project, to build Python tools to run on Intel GPUs, both embedded and discrete. So
okay.
So this may change in the future. It'll be interesting to see.
Yeah, absolutely. All right. Final call to action. People are excited about, digging more into these results and learning more about the state of the industry. What do they do?
Go search for State of Data Science, Anaconda, and you'll find the results of the survey. There's a lot of detail in there, so I would definitely go through and take a look at all of the charts and things, because there's all kinds of topics covered in there.
Yeah, I think it's 46 pages or something, and we just covered some of the highlights. So absolutely.
Yeah.
All right, Stan. Well, thank you for being here. It's been great to chat with you.
Thanks. It's been great.
You bet. Bye, everyone.